Hello everyone. I know once you have seen this video, you might be thinking, why this video on a physics channel? But I don't care. I just want to make this video because this is one of the first things that really impressed me in my life. The mathematical proof I'm going to show you is so elegant and simple that it'll blow at least some of your minds away. At least it blew my mind away when I first done it. So let's get into the video. Uh, so today Mikey came up with a different question. His question is, how do we know that there are infinite prime numbers? Okay, this is an interesting question. So I hope you know what a prime number is. If not, I'm going to explain it to you. Let's see. Back to basics. What's a prime number? How many of you know what a prime number is? Okay, so you know what number is, right? Like numbers go like this: 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, and so on. So if you take these numbers and just about any number, like let's say I have this number 4. 4 I can write as 2 into 2. If I take this number 6, 6 I can write as 2 into 3. And 8 I can write as 2 into 4, or which is also 2 into 2 into 2. But then you see other numbers over here like 2, 3, 5, and then 7. So 9, 2 I can write as 3 into 3. And this I can write as 10 equal to 2 into 5. So there are numbers which I can write as multiple of other numbers, but then there are numbers which I can't do that. So for example, 2 is just, you know, 2 is simply 1 into 2. I can't write it as anything else. I can't write it as multiple of anything else. So, simply speaking, those are prime numbers. The prime numbers are the ones which can't be written as a multiple of anything else. Like if I have a number n over here, the n would have factors. So back here, so let me tell you what a factor is. So right now, 2 and 2, these are factors of 4. 2 and 3 are factors of 6. And like 6 also has factors 1, 2, 3, and 6. All this can divide 6. So when I take a prime number, let's call it as Pn, okay? Nth prime. Then this would have only two factors, which is 1 and then Pn itself. Just like 2 has prime numbers 1 and 2, and then if you take 17, 17 is also prime. It has only two factors, 1 and 17, nothing else would divide it. So these are all prime numbers. So Mikey's question today is a little interesting. He's asking us like, how do we know that there are infinite primes? If you look at this, these prime numbers are really, what do you call this, special. They are the numbers that, so if you take any other number which is not a prime, it will have factors which are basically prime numbers, okay? So any prime number would divide many other numbers. So let's assume the proof was very simple. It goes like this. We assume that there are only n primes, okay? So let's say there are only n primes. So I would have 2, 3, 5, 7, 11, 13, and so on. Let's say Pn is the highest prime number, okay? Now I have like n prime numbers. This is my first prime, second prime, third prime, and so on, n primes. Then right now what I do is I'll multiply all of them. I'll write 2 into 3 into 5 into 7 into so on, Pn. Then I add a number to 1 to it. So I have this product of prime numbers and 1. Let's call this m, capital M, okay? So right now I have a new number m. So this number has two options. One, this could be like, divisible, or I could simply say that it itself is a prime, right? So right now, let's say, so this number. So for example, if I take number 6 is not prime. That I know because it's divided by 2 comma 3, right? So 2 comma 3 are prime numbers below 6. So if 6 is not prime, then that means 6 is divided by at least one of the primes which is below 6 number. So similarly, right now I have m number. Let's say Pn is the highest prime number. So I'll have two things. One, the m itself should be prime, because like if I divide this m with any of the numbers, any of the prime numbers, so it's very simple. So right now I have m as multiple of 2, 3, 5, 7, so on, n prime numbers, and then plus 1. So if I divide this with any of the prime numbers, so px, I'll always get remainder 1. So that means m is not divisible by n prime numbers. You see, if it's not divided by m prime numbers, then that means m itself should be prime. Or there is one more case, okay? The second case is that there could exist some prime number Pn plus 1 which is greater than Pn, okay? So which can divide capital M. So that means in both cases, in the first case, if M itself is a prime, then that means we have a prime number which is greater than Pn, okay? So then that means Pn is not the highest prime number. So I can continue this logic, and I can say that like there exists at least one prime number M greater than Pn. Or there is another case, since all the numbers, all the n primes are not dividing capital M, there could be one other prime which is greater than Pn, which can divide this M. which also means that there exists a prime number which is greater than Pn. So in both the cases, there exists a prime number which is greater than our highest Pn known. So you see, we can continue this logic forward, and I can say that let's say new prime number is Pn plus 1. Then I can always multiply all the numbers till Pn plus 1, and then I can find another prime which is greater than this one. So this logic will continue, and it will show that there are infinite primes. That is simple and elegant. No, in fact, all such simple and elegant proofs. So there is this guy called Paul Erdos, one of my favorite mathematicians. He says that God has a book. Okay, book. He calls it the book. Okay? The book is supposed to have all the perfect mathematical proofs. Perfect as in perfect like this simple. Whatever mathematical proof we have written just now. So just multiplying all the numbers, all the prime numbers, and just by adding one, we get some number, and thereby deduce that there are infinite primes. You see the elegance of this proof. So Paul Edo says that there is a book near God which has all such mathematically perfect proofs and simple proofs, and all we have to do is that try to pick one proof at a time, and somehow deceive God in picking up all these things. Okay? So, anyways,